this. Okay. Theoretical probability. Theoretical probability. This is actually, it's not that hard. It's understandable, okay? Probability is the measure of how likely an event is to occur. The set of all possibility outcomes is called the sample space. For equally likely outcomes, the theoretical probability of an event. Now, this is a symbolization of a theoretical probability. Probability of an event is the ratio or fraction, right? Ratio is just a fraction, division, of a number of favorable outcomes to the number of outcomes possible. Now, do you guys remember 6th, 7th, 8th grade and all that? You've been doing this like your entire math lives from middle school on up. And you always did that little thing called part to whole. Remember? Yeah, so. That's what this is, okay? We're just going to do, our fraction here is going to be favorable to whole, okay? Instead of part to whole, favorable to all of them, all numbers. Okay, so for example, number 1. Now they can get pretty not hard but long because they can throw stuff at you. A jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So our favorable is the red, right? So 32. And the total number of marbles, well, 32 plus 28, 60. And, of course, you got to reduce that. You guys remember how to do that in your handy-dandy calculators. 32 divided by 60, enter. Math, enter, enter, and we get 8/15. Now, like I said, that was an easy one. They can get kind of complicated. Okay, a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? Pat Sajak, can I have an E? See, we got an E, an O, an I, an A, an I, and another O. That's one. I want to buy a vowel. I want to buy 1, 2, 3, 4, 5 vowels. And then the total number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Bless you, my son. 11 letters, and this is already reduced, so we're done. See how easy that is?
You did in the month of January, randomly selected the probability of
Bless you, my son. So how many days are in January? I'm pretty sure there's 31. I looked it up last hour. I can't remember. Okay, what is a probability of selecting a prime number? Does everybody know what a prime number is? The only factors in a prime number is the number 1 times itself. Like 1 times 73, right? Okay, so we need the numbers in the month of January. See, this is where things can get kind of complicated. 1, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21st, 22nd, 23rd, 24th, 25th, 26, 27, 28, 29, 30, and 31. Okay, we're going to go ahead and circle all the prime numbers. Now, the number one's kind of special. It's neither prime or not prime, okay? So we're not going to use number one. 2 is a prime number, right? 1 times 2. 3 is a prime number. 4 is not because we have 2 times 2, right? 5 is a prime number. 7 is a prime number. 11 is a prime number. 13 would be a prime number. 3 times 5. 17 would be a prime number. 19. 23. 29. And 31. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hey, look at that. We got a prime number over a prime number. It's reduced. See how complicated, not complicated, but these things can get long because sometimes you're going to have to write things out. All right, number 4. 2 dice are rolled. What is the probability that the sum of the 2 dice on the next roll is 9? Now, we haven't done this yet, but when we have 6-sided die, right? 6 faces. We're going to multiply the 6 times the 6 because there's 2 of them. So and we'll get into that maybe tomorrow. So the total number of chances is 36. 6 faces times 6 faces, right? And we want those that are at least 9. So we got 9, 10, 11, and 12. Okay, so a lot of students would put, well, there's 4, right? 4 out of 36. But not necessarily, okay? The number 9 has more than one possibility when I roll the dice, right? First die can be 3. The second die can be 6. So there's one possibility. 3 and 6. How about 6 and 3? And then 5 and 4. And then 4 and 5. Now, I can't remember if, I think that you have to count these separate. Not sure. I'm going to think about that while I do this. The number 10, let's see, we can do 5 and 5. And then 2, and no, not 2. That's it, right? No, 6 and 4. Or 4 and 6. 11, 5 and 6. The first die 5, the second die 6. Or the first die 6 and the second die 5. 12, there's only one way, right? 6 and 6. Boxcars are called. All right. Let's see. This one has 4. I'm gonna do both totals here. And let's see, 7, 9, yeah, 10. Yeah, that's right. So we got to count. We do have to count the order of the dice that are thrown. So we got 4 plus 3, 7 plus 2 is 9, plus 1 is 10. And of course, we can reduce that to, put it in your handy dandy calculators. See, 2 goes into 10 is 5, 2 goes into 36 is 18. Okay, number 5. Number 5 says, what's the probability of drawing a heart or a club from a standard deck of cards? How many cards are in a deck of cards? 52. 52.
Well, 52 if you include the jokers.
54 if you include the jokers. Um, so that means half the deck is 26, right? So half the deck is black, half the deck is red, and there's 2 suits. So each suit is 13, right? A club and a heart is 2 suits, so that's 26. And 26 out of 52 is 1/2. We're not going to do number 6 because you're going to need a combination here. Yeah, this is just, we're not going to go there. Okay, sometimes we know what the outcome is, right? Like picking a red card in a deck of cards, that's easy. It's half, right? Sometimes it's easier to, if we want to find out, like like today, there's a 60% chance of rain. It's easier to take to find out the chance of not raining is to take 1 minus that probability, because the complementary of the probability is the not. Okay, that's called the complement. So you're going to 1 minus the probability of an event. Sometimes it's easier to do that than to try to figure out what the probability of them. Oh, by the way, there's symbolization in that. Since the sum of the probability is 1 or 100%, right? The probability of not happening is P. So you can either use this or this. P, and this little tilde says not the probability. If you guys remember that from geometry. Am I going too fast?
No, you gotta scroll down.
Oh, I'm sorry. Scroll down, not slow down. Okay. So you could either use P not E, or you could use 1 minus P, the probability of the event. Okay, either way. All right, the probability that it will snow tomorrow is 7 out of 20. What is the probability that it will not snow? So all we have to do is just, hey, they give us what the probability of snow is. So we're going to do 1 minus the probability that it will snow. This is pretty easy. Okay, the number 1, just think of that as 20 over 20. Okay, that's the number 1. And we could just take, hey, 20 minus 7 is 13. And we're using the denominator 20. 13 is a prime number. Doesn't divide into 20, so we're good. Pretty easy, right? A month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? Okay. So this is going to be easier, finding out what the probability of it beginning with A, April, and August, right? So 2 out of 12. And again, I'm going to think of this as 12 over 12. 12 minus 2 is 10. Or you can put it in your calculator. Doesn't matter. You could reduce this. This is pretty easy to reduce. by 6, right? Number 9, it says if the spinner to the left is spun, find the probability that it lands on a number that is not prime. Since we got this whole, it goes, first of all, it goes up to 16, right? 16, so that's our total. Not prime, since we have a list of prime all the way to 16, let's do the complement. We'll do 1 minus, and those numbers that are prime up to 16 is 1, 2, 3, 4, 5, 6. So, and again, I'm thinking of this as 16 over 16. 16 minus 6 is 10. 16ths. Let's see, divide by 2, I get 5. Divide by 2 is 8. Yeah, how many doubles are there? 6, right? 1, 1, 2, 2, 3, 3. So 6 out of 36 are doubles. The probability of not getting a double, 1 minus that. Again, think of this as 36 over 36. 36 minus 6, 30 over 36. You can simplify this with your calculator or do it in your head. 6 goes into 35 times. 6 goes into 36 6 times. And there you go. Questions, comments, concerns? I know I went through that kind of fast, but like I said, it really isn't that hard. On your homework. Now, remember, I'm not going to be here Friday, so those of you who are piling up your homework, can't imagine those students. You're going to have Friday, probably Monday work days to do your homework. Not a page, but homework 2. You should be able to do. You should be able to do 1 through 12. However, that's kind of a lot of work. So let's do 1. Let's do 1 through 10, okay? I'll knock 2 of them off. Today's the 17th. Questions, comments, concerns?